Hi, we're Haesung Becker, Jared Lyon, Atharva Deshpande, and Naveed Nikalesh. Our project is solving 3D Minesweeper with reinforcement learning and Bayesian inference for CS271. Standard Minesweeper is played on a 2D grid. We extend it to 3D boards of size 4x4x4 and 5x5x5. Each cell can now have up to 26 neighbors instead of 8, which makes local reasoning much harder. The agent only observes revealed numbers and flags, so the game is partially observable, and the goal is still to reveal all safe tiles without clicking on a mine. We wrap the game in a gymnasium environment for a 3-dimensional Minesweeper board. The action space is one discrete action per tile, and the observation is the full 3D board encoded as integers. In step, we give a large negative reward for hitting a mine, a positive reward for winning, and otherwise reward the agent by the number of newly revealed safe tiles. We also return an action mask so agents can't click the same tile twice. We compare two main agents. First, a Bayesian approximation agent. It scans the revealed numbers, approximates the probability that each hidden tile is a mine, and always plays the lowest risk move. Second, a dueling DQN that operates on the full 3D observation. Our network uses 3D convolutions, followed by a dueling head that estimates a state value and per action advantage, and we train it with experience replay and a target network. Our dueling DQN learns meaningful behavior on the easier 4x4x4 5-mine board. Here, it consistently clears the board after training, which shows it has learned some structure in the game, rather than just random clicking. On a larger 5x5x5 board, with the same number of mines, the DQN still does better than random. It reveals many safe tiles and occasionally wins, but it's noticeably less reliable than on a smaller board. The Bayesian agent using approximate probabilities is much more cautious. On 5x5x5 with 5 mines, it wins far more often. It tends to clear layers methodically and avoids obvious risky guesses when there's a safer tile available. When we increase the difficulty to 5x5x5 with 10 mines, the DQN really struggles. Even after training, it almost always hits a mine and essentially never clears the board in 5,000 evaluation episodes. The Bayesian agent still manages to win sometimes, even in this high mine setting. It's not perfect, but it can thread its way through dense mine configurations a lot more reliably than a learned policy. Here's the quantitative summary over 5,000 episodes per setting. On 4x4x4 with 5 mines, random and heuristic basically never win. The Bayesian agent hits about 44% win rate, while the DQN wins only a small fraction of the time but still clearly beats random. On 5x5x5 with 5 mines, Bayesian is even stronger at around 66% wins, and DQN wins sometimes but stays well below Bayesian. In the hardest 5x5x5 10-mine environment, Bayesian still wins about 12% of the time, while DQN effectively doesn't win at all. Overall, Bayesian dominates in win rate, and DQN sits between Bayesian and the simple baselines. To wrap up, 3D Minesweeper is hard even on small boards because each cell has many neighbors and the information is ambiguous. Our dueling DQN does learn non-trivial behavior and can solve the easier boards, but it doesn't match the Bayesian approximation on these sizes. The Bayesian agent is our strongest model in terms of win rate, especially on 5x5x5. If we had more time, we'd have liked to combine the Bayesian probabilities with a learned policy, explore curriculum learning with gradually harder boards, and experiment with different reward shaping and longer training to help the DQN scale to denser mine configurations. Thanks for watching.